Alright, so today we're going to look at, as I said, we're going to look at solving equations, but we're going to have pronumerals or letters on both sides. So we can see we've got letters on both sides of the equal sign. Now we know we're still going to go about it the same way. So when we have the equal sign and we move things, we will do inverse or opposite operations to solve. And obviously at the end of the day, you just want one x equaling, or whatever letter it is, and equaling something. So when we see these ones down here with letters on both sides, well, the first step is to get the letters, all the letter terms, so I'm talking about these two terms, at least on the one side. So I'm going to put them over, I want them on the left hand side. So I'm going to move this over an equal sign. Now, because it is assumed that it is plusing here, so we know when we move it over the equal sign, it becomes minus. Now, I haven't moved that -2, so I'll leave that. So then I'll tidy this up. So 5y minus 3y is 2y equals -2. Now, remember, we want just the letter by itself. So I'm going to move this 2 over an equal sign. And over here on the left hand, it's timesing. So if I move it over the equal sign, it will divide. And if we have -2 divided by 2, we get -1. So remember, if you have a negative divided by a positive, it equals a negative. All right. So here in the next example, I'm going to move this y over. So first that I get the y's on the one side. So that would become the opposite, which is plusing, and I haven't moved the 7. So if I add 6y and another y, I have 7y. And then I'm going to move that this 7 away so that I've got y by itself. So when I do that, I end up with 7 divided by 7. So y equals 1. And there's my answer. All right, so we're not doing anything new. We're still doing the same. So if we have a look at this one, we want to get the x's and on one side and the numbers on the other. So depending on which way, it doesn't matter which side, because remember the other day I told you, it doesn't matter if you have x equals something or something equals x. It means the same thing, but it's up to you. So we'll go and try and put the x's on the left hand side. So that means I'm going to move that one, this guy, over. So when he's on the other side, he will minus. So I've got minus 3x. So I've just moved the 3x over. So because I want x's on one side and numbers on the other, I'm going to move this 4 over to that side as well. So I've got now x minus 3x equals 8 plus 4. Okay, so then I might do these sums. So if I have x minus 3x, I get -2x. And if I have 8 plus 4, I get 12. So then this 2 is multiplying. So if I move it over, it will divide. And then that's a positive divided by a negative gives a negative. So x equals -6. All right, so I'm going to get one of you guys to step me through this question here. Does anyone want to volunteer?
Yes.
Yeah? All right, you talk me through it, Liam. What one are you going to move first?
Don't you move the 4x?
Yep, good. So you're going to move the 4x over, and what will it do?
It will plus with, oh no, is it minus?
Yeah, good. Yep, so we've moved it over and it's minusing now. Good.
Yeah.
And so now what will I do?
You'll move the 12 with the 5.
Yeah, good. So what I'll have is, I haven't moved this, So I'll have 5, and what will that be then? If I move the 12 over, it'll do the opposite, which is?
5 plus 12.
No, it's plussing on this side, Liam. So what will it...
Okay, so minus 10.
Yeah. All right. So now tidy those little sums up.
Negative x
Yeah.
equals negative 7.
Excellent. So now we've got to remember that there's a 1 there. So what would be my last step to do? Because I want just positive x. So what we're going to do, this might be, we're going to move this negative 1 over the equal sign. Now this negative 1 is timesing there. So when it's on the other side, it's dividing. Now if we have a positive divided by a negative, what do we get? Boys, anyone?
We'd have a negative divided by a negative.
Oh yeah, sorry. We do too. So what do we get if we have a negative divided by a negative?
Positive.
Beautiful. So we get x equals positive 7. Good work. All right. So that's those ones. So you just got to keep spinning through. We're doing the same. Now, what do you think? Who's going to suggest? What do you think we would do first with this one? We're going to try and solve it. Yeah, good deal. What did you say to do with the brackets? I didn't hear.
Well, you do 5 times x and then
Yeah.
5 times 2.
Cool.
So
So we're expanding the... Yep. Good.
5x minus 10.
Yep, good. We've expanded the brackets out. Now what are we going to do? What shall we do now?
Move the 2x
Yep.
over.
So what will that do over there?
So 5x minus 2x.
Yep.
Yeah.
So then what will I might do?
Move the 10 over, so that'll be...
Yeah.
5 plus 10, so it'll be 15.
Yep. So we've done 5 plus 10. Good. So you've worked out that side. What about the left-hand side over here?
Yeah, so 3x equals 15.
Good. And then...
Then you divide the 15 by 3.
Good.
X equals 5.
Excellent. Well done. So then there's that one. Awesome. Well done. So that I can pop it on the video. All right. So in this question 7, this is exercise 4.3. We're working through question 7. All right. It says a new edging is to be placed around a rectangular children's playground. So with these questions, boys, it's always really good to draw a diagram. Even if they don't ask you, just draw it. And the width of the playground is x meters. So maybe I'll call that x. And the length is 7 meters longer than the width. So that would be x plus 7. Yeah, so there's the length. Now, it says question A, it says write down an expression for the perimeter. So you need to write down an expression for the perimeter of this thing. So if you think about it, the perimeter is when you add up all the sides. So if this was x, that one, the other in length, and this would also be x plus 7. So I could write so I might just call P for perimeter. So really, if you look at it, you can either say we've got like 2 widths plus 2 lengths. But for us, the width is x, so I'll write 2x plus now the 2 lengths. Now I'm going to have to put that in brackets. So we've got 2 of them like that. Okay, so that's one way you could write it. Some people might have just added them all up. So you could just add them all up like this. And we would have got the perimeter equals 4x plus 14. Okay, now if you have a look, you still would have got that with this one here. Because if you expand that out, you'd have this 2x plus another 2x plus 2 times 7, which is 14. So you end up with the same thing. So it depends. They didn't really say how they wanted it. So any expression would have been fine. So even if you had it like this, even technically, if you had it written like that, you're still correct. They haven't said simplify it, so technically you're okay. Oh, it did, sorry. It does say write the answer in factorized form. So factorized form would be this one here. Okay, because we've got the well, it could be maybe not even. That's not quite fully factorized. So let's have a look at this one. So we've found out the perimeter is this. If we were factorizing this term, what's the highest common factor in those two terms there? So I'm talking about these two. What's the highest common factor? Pardon?
7.
No, 7 doesn't go into 4.
2.
2, good. So when you factorize, you take the highest common factor. So this would be 2 times 2x plus 2 times 7. So remember, when we factorize, we take the highest common factor out and we leave what's left there. So here is our factorized form for the perimeter. Okay, now the next, it says B, if the amount of edging, so we might just keep, I'm going to keep that, our, what did we have? Sorry. We had, I'm keeping my factorized form there. It was 2x plus 7. All right, so it says for part B, it says if the amount of edging required is 54 meters, determine the dimensions of the playground. So remember, our playground was like this, and x plus 7. And they've just said, when they said you need 54, well, that's to edge the whole thing. Well, they're pretty much telling me that the perimeter is 54. So therefore, I could write 54 equals, and you can use your factorized one if you like, but we would probably expand that out, which is 4x plus 14. And then we're going to keep solving like we did with our normal equation. So I might bring that over, and it'd be 54 minus 14 equals 4x. So that's 40 equals 4x. So 40 divided by 4 equals x. So 10 equals x. So your dimensions are 10, and this one would be 17, wouldn't it? Okay, so that's